One very important skill for us to develop is when to recognize that we have a line on our hands. So here we're going to practice recognizing lines and also see what's called slope-intercept form of a line. So lines always look like this. Lines are always of the form ax plus by is equal to c. Now the a, b, and c, those can be any numbers at all. Positive, negative, fractions, irrational numbers, whatever. Now what's important here is that you have x and you have y, but that the exponent on the x and the y, the exponents are 1. Now we usually don't write that, but it's really a 1 there if you wanted to put it in. And the second important feature is this, that it's addition or subtraction between the x and the y. So for example, this would be a line. 2x plus 3y is equal to 6. Okay, so I see it's addition or subtraction, separating the x and the y, and the exponents on the x and the y are simply 1. So this is a line. Now let me give you some examples of things that are not lines. That's kind of just as helpful to see. So if you have something like this, x multiplied by y is equal to, let's say, 10, that's not a line. Now, why not? Well, it's true that the exponent on the x and the y, it's a 1, but do you see how it's multiplication right here? It's not addition or subtraction. That's what makes it not a line. Another example would be something like this. 3x squared plus 2y is equal to 6. Why is this one not a line? Well, because the x is raised to the second power. It's true it has addition, but that's not the only criteria. It's got to be addition or subtraction, and the exponent has to be a 1. Another example of not a line would be this. 2x minus 3y squared, or let's say y cubed, is equal to 8. Again, the problem is the exponent. It's a 3 on the y. Okay? So it's got to have x raised to the first and y raised to the first. Another example of a line would be this. 1/2 x minus 2/3 y equals, I don't know, like 0.4. Okay, this is a perfectly legitimate line. That is, when you graph these equations, or the solution sets to these equations, you'll find that you get a line. In these three examples here, when you graph these, you won't get a line. You'll get other geometric shapes. Okay, now that we know what a line looks like, oh, one last point, by the way, before we move on. So this is generally the equation of a line, okay? Now sometimes the a, the b, and the c, like in this example here, sometimes they are integers. That is, not fractions, not irrational numbers. So when you have that situation, we usually write it with a capital. Ax plus by is equal to capital C, and that's called standard form for a line. We're going to use standard form occasionally, but the important thing for you to recognize is this, that the criteria that we talked about for when you have a line. So you should have confidence in that, right? Whenever you see that, you say, oh, I know what the graph of this looks like. It's simply a line. A line, okay? So that recognition is important. All right, let's go ahead and see an example of what we can do to one form that a line can take on, called slope-intercept form. So let's think about this equation. Now I know this is a line, right? Because x and y are raised to the first power, and it's addition or subtraction between them. So what we can do is, for slope-intercept form, which we're gonna put this into slope-intercept form. For the first thing you want to do is you want to isolate the y. Okay? So let's take that again. 2x plus 3y equals 6. And to isolate the y, the first thing we have to do is subtract 2x from both sides. So I get, well, on the left-hand side, it's 3y, and the right-hand side, negative, let's try that again, negative 2x plus 6. Now you might say, why didn't I write this as 6 minus 2x? Turns out when you have slope-intercept form, you always write the right-hand side like this. You always write the x first, or the term containing x first, even if the coefficient is negative. That's just part of the form. Okay, now we're going to divide both sides by 3. And so the 3's cancel. And now this 3, because it's addition or subtraction, the 3 goes into both of those. So I get y is equal to negative 2x over 3 plus 6 over 3. Now what we typically do is we break off the negative 2/3 and write the x just off to the side. So we get this. Y is equal to negative 2 over 3 times x plus, and then 6 over 3 is positive 2. Now, so this has been written in what's called slope-intercept form. And it turns out the number right here, you see the coefficient of the x, the negative 2/3? Now, when I say coefficient, that means the number being multiplied by the x, okay? So the coefficient is purely a number. That number, that m, that number rather is what we call, well, it is rather the slope of this line, and we denote that with an m. The positive 2 here in this case is the y-intercept. And that's always going to be the case. When you take a line and you isolate the y and the right-hand side looks like this, you've written the line in what's called slope-intercept form. So generally, slope-intercept form is this. Y equals m multiplied by x plus b. Okay? Now, m is what's being multiplied by x, and then plus b, well, the b is the y-intercept. So let's go ahead and give that a box. So this is called slope-intercept form. Slope-intercept form. Now it's a little tricky because people say slope-intercept, but you have to know it's really slope y-intercept, right? So this is the number here is really the y-intercept. So let's go ahead and see an example of just how to identify the slope and the y-intercept if you had a line written like this. Okay, so in this problem, they just ask us identify the slope and the y-intercept. So remember, you're aiming for this, right? Y equals m times x plus b. So when I look at this, I say, I'm looking for something to multiply by the x. And there's really, I can always put a 1 right here, right? So it's like having 1x. I can always do that. And if I did that, then I could write it like this. Y equals 1/4 times x minus 2. So isn't 1/4 times x, because this is like x over 1, isn't 1/4 times x the same as x over 4? Sure it is. And then we still have the minus 2. Now when I compare these two, I can see that my m, right, that is the number you're multiplying the x by, it's 1/4. That's the slope of the line, 1/4. And what's the b, the y-intercept? So the b is not 2, it's negative 2. Let's write that. So the b equals negative 2. And you might say, how do you know that? And the answer is because this form says plus b. And if it's minus 2, you really have to think of it like this. 1/4 x plus negative 2. You see? So a way to think about it, an easy way to think about it is whatever's here always goes with the number that follows. Okay? So if it was positive 2, I would have written plus 2. But because there's a subtraction sign, you can think of it as sort of attaching to the 2, and that would give me, negative 2 for my y-intercept. Okay? So that's the first thing, recognizing the slope and the y-intercept. Okay, let's do ask ourselves now, you might say to yourself, well, why is that the case? Why is this number the slope, and why is that number the y-intercept? And that is a very important question. Let's see if we can answer it now. So why? So what I'd like to do here is I'd like to convince you that the 3 really is the slope, and the 7, the positive 7, is really the y-intercept. Okay, the y-intercept, convincing you of that is not going to be that hard. So let me show you why. So if you take, if somebody asked you to find the y-intercept in any situation, all you have to do is set x equal to 0. So if I set x equal to 0, I get, let's see, y is equal to 3 times 0 plus 7. And so I get y is equal to 7. And that means the y-intercept is simply 0, 7. And no problem, right? I can see the 7 appeared right here. So, oh, look, the positive 7, that really is the y-intercept. In other words, just looking at this, you can see that the y-intercept has got to be positive 7, because if x is 0, what are you left with? Just positive 7, right? Y is positive 7. Okay, the real work comes in convincing you that the 3 is really the slope, okay? So what I'd like to do is I'd like to convince you that the slope m of this line is really 3. Now remember, slope is by definition the change in y over the change in x. Now when we write that, change in y simply means y2 minus y1, and change in x is x2 minus x1, right? So I could write it like this: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now to calculate the slope of a line, you need 2 points, right? Now I already have 1 point. I just found the y-intercept, 0, 7. So let me create a little table of values here. So x and corresponding y's. So I've already found one pair, right? X is 0 and y is 7. Now I can pick any other pair that I want. Let me just pick x to be 1 because that'll make our calculations easy. And you can always do this. You can always choose x to be 0 and then x to be 1. And then what, in this case, what do we get when x is 1? Well, let's see, 3 times 1 is 3, plus 7 is 10. Okay, so I'm going to use these two ordered pairs, 0, 7 and 1, 10, to calculate the slope. So let's see, m is equal to, let's see, y sub 2, 10, take away y sub 1, which is 7, right? Divided by x sub 2, which is 1, take away x sub 1, which is 0. And now you can see why I chose 0 and 1 for x, right? Because look how easy it is in the denominator right there. And then 10 take away 7 is 3, divided by 1. Oh, the slope is 3. And that's exactly what it is here in this equation, 3. Now, you can always play that game. You can always find that you can choose 1, and the number that you get here, the second y, is going to give you a number such that you can use all 4 of those here to calculate the slope. And you'll always find that whatever number you get for the slope using this little combination, or any two ordered pairs you want, in fact, that slope is always going to be that number right there. In fact, if I wrote it generally, right, if I wrote y equals mx plus b, right, and I find, oh, the first point is 0b, that's my y-intercept, right? Well, when x is 1, right, if you plug in 1 for x, what is y? Well, if x is 1, y is going to be m plus b. And that might look a little strange, but remember, m plus b are just numbers, right? And then if you calculate the slope using these 2 points, what do? Well, you take this and subtract that, so you get m plus b, take away b, divided by 1 minus 0, and what do you get? Well, b minus b is 0, so you just get m over 1, and that's, of course, the slope. Now, you might say, wait a minute, we're calling that the slope, and that's true, but my point of this example here is that notice how whatever you get when you do this, that's always going to be, it's always going to be that number right there. Okay? So that should convince you that whatever is right there, whatever number is right there, is always going to be your m. Okay, so that's slope-intercept form, and we're going to put this to work when it comes to graphing and also with applications. Until next time.